everyone, welcome to Unit 2. We are starting today on page 103, and we're going to talk about lesson 9.1, where we're going to start talking about our transformations. You're going to want a pencil and a highlighter handy today. Now, our lesson actually talks about the Marching Cougars, but not of Plainfield South High School, of Chavez High School. And when you think about a marching band, okay, those of you that have seen football games, all right, we have our marching band, and sometimes the marching band might be marching this way, sometimes they might move back, but they're staying the same distance from each other, right? No matter where we slide our marching band, they're the same distance from the people in front of them or behind them, right? There's not changing yet of our band. So that's kind of what we're getting at today. So again, we're starting with the Marching Cougars, but of Chavez High School. So let's just change that to PSHS, right? And this is our formation of our band here, kind of on a coordinate plane. So think if you're standing on the football field, you're standing on those markers for the yard lines, kind of have them on there. So we have 6 marchers wide, 9 marchers deep on this. Okay, now the band starts marching, and they're going to, move apart from each other vertically, while keeping the same distance though between them. So here's our original picture here in part A. And notice they're moving vertically down to move from picture A to picture B. Well, what this is showing us is the transformation, okay? And the original picture is what we are going to call our pre-image, and then the movement then results in a new image. So that's our kind of post-transformation. So very important vocab words that we are going to use a lot over this unit. Now, in your own words, describe what kind of transformation happened from A to B. What you probably said is that this is a slide or a movement down of our picture, right? Movement down on our coordinate graph. Now, as we start looking at page 104, then, I'm going to leave this here, but on page 104, we're looking at number 2 now. It says here that we have these 2 transformations, right? In between transformation 1 and transformation 2, what's happening versus what's happening between B and C, the same transformation here of taking our image from here and now transforming it again. Well, what we're seeing here is that first transformation preserved the size and the shape. It stayed the exact same size. So it was still 9 units tall and 6 units wide. But here we stretched things vertically so it moved. So there's a difference between transformation 1. It kept the size and the shape the same. Okay, but transformation number 2 stretched it vertically. Right, it made it longer, right? So what that's kind of telling us is that the first transformation that kept the size and the shape, that's what we would call a rigid motion because the distance stayed the same. So again, the distance between our marchers didn't change, so that shows that it was rigid. Distance did not change in transformation 1. But transformation 2, we had the distance between the same marchers in the same row were the same, but we stretched them vertically so that changed. So in transformation number 2, this is a non-rigid motion. Oops, rigid, this is supposed to be an I, because we stretched vertically. We changed the size of our box. Our marchers are not the same distance away from the people in front of them. Okay, so that's what we would call non-rigid versus transformation 1, which was rigid. Okay, now if we look back at figure A and figure B, okay, so figure A, they're telling us the coordinates of these. They're located at 1, 2, 1, 10, 6, 2, and 6, 10. And then if we look at this part B here, we're now at 1, 4 and 1, -4, and we're at 6, 4 and 6, -4. So we have these boxes filled out here, right? If we fill in those points of where we're at in figure B, going back to there. So what we're noticing here is the x coordinates are staying the same, but the y coordinates are all decreasing. In fact, they're all decreasing by 6 each time. So we went from 10 to 4, we went from 2 to -4. So we're decreasing by 6 with our y coordinates, but those x coordinates stayed the same from our pre-image to our image. So what we can say is that what happened to our point is that the x value stayed the same as it was in the original, but the y value decreased by 6, aka we had to subtract 6. So notice this arrow here from the math box tells us that this means goes to. We started here and then we went to this point here. So that arrow shows us that a transformation occurred, and this is how we would write the rule, okay? Now going back again to this original picture here, we had the image B, and again we had those points written down, 1, 4, 1, -4, 6, 4, 6, -4. Now we also want to represent these points here because 1, 4 moved to 1, 8, 1, -4 in the original picture over here moved to 1, -8, and then we have 6, 4 becoming 6, 8, and 6, -4 becoming 6, -8. So that's what's happening here in this picture. We'll have all those points now written down of that transformation. And what we're going to notice again is that the x coordinate stays the same, right? This is going to remain the same, but our y coordinate this time doubled. Okay, so our y coordinate was multiplied by 2 each time. So even though this is not a rigid function and we can't use addition or subtraction, we still can write this as a function because each time the x value stayed the same, but we doubled the y value. We multiplied it by 2, so we can still represent it as a function. Even though it's non-rigid, we're going to show that with our multiplication, okay? So now we want to be able to take a picture and draw the image based on the function rule. So look at this first function rule. And what do you notice about this function rule each time? Well, hopefully you're noticing that your y value is going to actually stay the same, but your x value is going to add 3 to it. So we're going to take all of our original points in this picture and we're going to move it to the right 3. So we're going to now have this guy start at 3 units to the right. So it's going to start over here. If we draw a picture, 1, 2, 3, 4, 5. Still at 2 though. And then 1, 2, we had to move our other point there. And then we had to move our 2 points up top here again to the right 3 units so that our image looked like this, okay? So here's our image. Sometimes it's easier to do it on the original graph to move things over. So if you wanted to graph it on here as well, here's what your image would look like if you graphed it on here. Same points, just showed it differently, okay? Now, letter B, what would be happening here? Well, what's happening here is that this is no longer the same size, right? This one is going to transform, well, we're going to double it, where instead of being at 1, 2, our rule now is that we're doubling this. So this new location is going to be at 2, 4 in our image. And this point was at 1, 1, 2, 3, 4, 5. So that means our new point has to be at 2, 10. And this guy was at 3, 5, so now it needs to be at 6, 10. So that's going to be this point here, 6 to the right, 10 up. And 3, 2 now is at 6, 4. So right here. So looking at these two, our first transformation would be considered rigid, because imagine if we drew the number 4 in this, like they're asking us to in number 7, the 4 would stay the same size as it was in the original as it is in the transformation because it was rigid. Letter B is again non-rigid because we changed the size. The 4 that we wrote in letter B would get much bigger in the image in letter B. Okay, so that's what they're getting at here. Describe what should happen. For the first one, it'll stay the same, but the second one, it would double in size because that's what happened to the X and the Y values. It increases in size. And we'll talk about this vocabulary at another time, but we'll kind of just have some of the big vocab words for today. And I'll post this for you guys. You won't have to have a vocab organizer, but it is really helpful to keep track of what each of these vocab means and then visually. And then finally, as we finish out this lesson, they want you to graph this picture yourself. So first off, in words to describe what happens, make sure you do that. And then you also want to now transform this on your particular graph. So we had to move everything to the left 2 and up 1. So again, you could do that on this graph here, where everything's to the left 2 and up 1. So it looks like this, which again, you could also transform onto this graph as well, where those points ended up as well. Kind of personal preference on where you'd rather regraph it to. Left 2, up 1. And then we'll skip over that portion. Number 8 is just asking us to look at the pieces. Number 9, we read over that, says graph the transformation. Is this going to be rigid or non-rigid? What do you think? Hopefully you said that this was rigid because we did not change the size or shape, just where it was located. We just shifted it to the left and up. Okay, and last but not least, for some reason, number 10, actually the questions for number 10 are on the top of the next page, and it says which function describes the transformation, and then classify it as rigid or non-rigid. So we're going to go back to this one. And a couple things you guys could say here, but the transformation rule that we would see here is that if we're going with a slide here, what we did was we moved you could say we moved this piece down. If this is now this piece, we didn't change the X values at all, but we subtracted 12 from our Y values. So if we started at 10 and now that point's at -2, we had to subtract 12 to move that down all the way. So here to here, we did not change our X values at all. So that's where these moved down. And again, this transformation would be rigid because again, did not change size or shape. Oops, never change size or shape. All right, thanks everyone. We'll work more with these transformations in class.